Alright, so in this video we covered the second part of chapter 3, in this case, measures of variation. So what we have covered in the previous part is the descriptive measures of center, and in this case, well, the most important were the mean, the median, and the mode. However, in this case, well, there's other measures that we need to look when we do some some analysis, some study, because there are data sets that can have the same mean, the same median, and however they may have differences in other aspects. So let's look at the example. Let's consider the example below. So we have 5 basketball players and their height. So we're looking at their heights, and in this case they're given in feet and inches only. Well, if we calculate the 3 different measures, well, in this case, the mean, the median, and the mode, they are going to be the same for both. They're going to have the same mean, which is 75 inches, the same median, which is 76 inches, and the same mode, which is 76 inches. So if you look at the median, 76 in the middle, 76 in the middle, and the mode here is 76, the mode is 76, and well, if we calculate the median, well, I don't want to spend too much time doing that, but let's just trust this number, 75. However, well, they have the same measures of center, the same mean, the same median, and the same mode. However, if you observe the players, they have differences in other aspects, like their overall, like the differences in their heights. So what we're going to do in this section is how dispersed the data is. For example, if you observe the heights of the players, well, in the first team they are all about the same height, and yet they have the same measures of centers as the other team that have differences in their height. This is way shorter, and then this is way taller. So there's a difference. The dispersion of their heights is more noticeable here than here. Alright, so we're going to look at the first measure of variation, also known as measures of dispersion. And one of them is the range. So the range of a data set is the difference between the highest value and the lowest value. All right. For example, if we find the range of values for the first team, 78 minus 72. Okay, 78 minus 72. The range is 6. All right. So that's going to be the range for the second team. Well, 84 minus 67. Well, let me use the calculator for this one. 84 minus 67. That's 17. So the fact that the second team has a larger range, that means their heights are more dispersed, or there's more variation in their heights, as opposed to over here their range of values is 6 is a smaller number, and if you observe their heights, that means their heights are more consistent, or more uniformly distributed. Well, we're going to talk about the uniform distribution later on. So let's look at another example. So the following table lists the balance due on a credit card over a 5-month period. Calculate the range of this data set. So we need to identify the smallest value in the data set, or the lowest and the largest. So the range will be largest minus lowest, which is 1075 minus 485, which equals 590. And actually in dollars. Well, this example is very silly, very simple, but it doesn't really, illustrate what the range is. So I guess with the comparison we did for the teams, as far as their as what their ranges are, well, that tells us a measure of dispersion, so how dispersed are to one another. All right, let's look at the next page, and then we're going to look at one of the most important pieces of information that we are going to use for the rest, almost for the rest of the semester, which in this case is the standard deviation. So the standard deviation of a set of values is a measure of how much of the data values deviate away from the mean. It is calculated by using these two formulas, well, depending on whether depending on whether we are looking at a sample or the population. So, well, again, that was something that calls my attention the most is the measure of how much the data values deviate away from the mean. Okay, let me use the back side of the page just so I can illustrate again in the case of the of the basketball players. Well, team 1 has an average or mean of 75. Actually, both have the same mean. However, the remaining members of all the members of the team, well, if the mean is 75, so one of the players is a little bit lower, 72, and then 73, 76, also 76, and then 78, right? So this is how the data is deviated away from the mean of 75, as opposed to team 2, whose mean is also 75. All right, and the heights of the team members, well, one goes too low all the way to 67, and then 72, and then again 76, again 76, and this one goes all the way to 78. If you look at this data, this data set is more deviated from the mean. So that's what the standard deviation tells us. So if we look at this data set, well, the data set for team 1, their heights will have a smaller standard deviation than the second team. Look at the dispersion. It's going to have definitely a larger standard deviation. All right, so let's discuss more details about what the standard deviation is. So in this case, what we're going to do, let's make a distinction. So for population, we use the lowercase sigma from the alphabet, from the Greek alphabet, and big N for the population size. As opposed for the sample, we use the lowercase s, but in this case, as opposed to the previous case, we divide by n, the sample size n, minus 1. Now, and here is an explanation as of why do we divide by n minus 1 instead of n. And it happens that when data values are more clustered around the sample mean than around the population mean. So what we do by dividing by n minus 1, there's a little typo here. This one should be n minus 1. So what we do is to inflate the estimate for the sample, because most of the times the sample may not be very, very well representative to draw a conclusion about the population. So we divide by a smaller number to basically inflate the estimate and get a better estimate. All right, so let's actually do one example. So in this example, I'm going to show you how to find the standard deviation the long way using the formula, but then in another video I'm going to show you how to do it using the graphing calculator. Alright, so let's see. So determine the sample standard deviation of the height of the starting players on team 1 from the picture on the previous page. It should say the previous page. I thought I changed it, but anyway. Okay, so to do this, well, we're going to use this formula, the second one, because in this case we have a sample, not a population. Alright, so in this case we need, so the standard deviation is the square root of the sums of the squares of the differences of each data set minus the mean, the whole thing divided by n minus 1. Well, it's a little bit complicated to read this formula, so I'm going to take, in this case, baby steps to compute this formula. So what we're going to do, first we are going to compute the differences of the mean with respect to the mean. So we need to write down what the mean is. Well, in this case, it's given from the previous page. It's 75. Right? Remember from the introduction of the section, we were given this data value. Okay, deviation from the mean. So what we do is x minus x bar. So these are all x's. That is 72 minus 75, 73 minus 75, 76 minus 75, 76 minus 75, 78 minus 75, and then just compute these differences. So in this case, what do we get? 72 minus 75, that's a negative 3. 73 minus 75, that's a negative 2. 76 minus 75, that's 1. 76 minus 75, that's also 1. 78 minus 73, that's 3. So now these differences that we compute, now we need to square them. That is negative 3 squared, which equals to 9. Negative 2 squared, which equals to 4. 1 squared, which equals to 4. 1 squared, which equals to, oh, not 4, actually 1, not, what the hell did I say? That's 1, that never happened. 3 squared, which equals to 9. And then we are going to add all this, because that's what we need to do. All these differences squared, we need to add them. Keep in mind, recall that this symbol right here, it looks like an E, but it's ultimately sigma, means summation. So we do the summation of all these numbers. 9 plus 4 plus 1 plus 1 plus 9, that's a total of 24. Okay, that's actually the sum of all the x minus x bars, the whole thing squared. So now we're ready to compute the standard deviation. In this case, little s equals to the square root of the summations of the differences of each data set and their means, quantity squared, divided by n minus 1. So what's n in this case? N equals to 5, because there's 1, 2, 3, 4, 5 elements to find the standard deviation of. So this calculation, or this, what I'm highlighting here, is this 24 that we're seeing here. All right, this is equals to 24 over n, which is 5, minus 1, which equals the square root of 24 minus 4, or over 4 rather, divided by 4, which is the square root of 6, which approximately, so s, it's approximately, using this calculator, 2.6. All right, so that's one example of standard deviation. If otherwise, If otherwise, well, we didn't have a sample. If population, we would have been doing sigma equals the square root of still the summation x minus x bar squared over big N. And then, so if this were the population of basketball players, well, we would have said, well, still the square root of 24 over big N. In this case, it would have been 5. So the calculation would have been similar, but except we don't subtract 1 to the denominator. So let's do the calculation here. The square root of 24 over 5. And that's 2.19. 2.19. So, but in this case, we're looking at a sample. So we're going to go with this one. For the population, well, I'm showing you what to do in either case. However, the good news is that you won't have to do this long process to find the standard deviation again. I'm going to show you how to do that in another video. Let's move on to the next page and see what's in there. Variance. Okay, so the variance is the square of the standard deviation. And well, in some calculations later in the semester, we may need to work with the variance, or in some cases we may need to work with the standard deviation. So depending on the situation, well, so let's determine the sample variance of the heights of the starting players on team 1 from the previous page. Well, so we got a standard deviation S of, I believe it, well, let's actually use the square root of 6, you know. Well, the variance is no other than the square of the standard deviation, which in this case, boom, boom, cancel the radical with the exponent. So the variance is 6. All right, can we find standard deviation of a frequency distribution? Yes, remember we did in the previous video how to find the mean of a frequency distribution, and we need some sort of the weighted mean. All right, now for the standard deviation, we'll look at the formula. It's really ugly. And the number of data sets, the sum of the product of the x squared times the frequencies minus the sum of the products of the frequencies and the data values, the whole thing squared, the whole thing times n times n. Well, just looking at this formula, it makes it not even be in the mood for calculating in this way. Luckily, there's a way to do this way quicker, in a way quicker way, using the graphing calculator. So here I'm gonna leave the video here because I did this problem in a separate video. All right, so I'm gonna call it a day for this video, and then I'm going to show you in the other video how to solve this problem.